In this skill, we're going to be combining calorimetry from the previous unit with the enthalpy change of reaction and stoichiometry from this unit. In this question, we have a small sample of phosphorus, P4, and an excess of bromine, Br2. Our first step is to balance the equation. Again, I'm not going to show how to do that here. You can head back to Unit 14 if you want to see an example on that. To balance this equation, we need 6, 1, and 4. We've been given the enthalpy change of reaction for this equation. We're then told that the scientist reacts the bromine and phosphorus together in a reaction chamber that is placed inside a container of water. So you can see in this image here, the reaction chamber. Inside there is where the reaction between the phosphorus and the bromine is happening. As the reaction happens, it's either going to generate heat or it's going to absorb heat, and the temperature of the water is going to change as a result. So we're told that we have 122 grams of water that has an initial temperature of 20 degrees C. We're also told the specific heat capacity of water is 4.19 joules per gram degree C. And we're told that after the reaction has finished, the final temperature of the water is 27 degrees C. So we know here in this question that the temperature of the water increased during the reaction. So we can use the change in temperature of the water to figure out the enthalpy change during the reaction. So let's start out by finding the equation for the enthalpy change based on the change in the temperature of water. That's going to be the specific heat equation, Q equals mc delta T. So to find the change in energy, we need to use the mass, the specific heat capacity, and the change in temperature. So the mass of our water sample is 122 grams. The specific heat capacity of water is 4.19 joules per gram degree C. Then we have the change in temperature. We know that we started at 20 degrees C and we ended at 27. So the change is going to be 27 minus 20. And remember, those bars, those vertical lines on either side of the delta T and either side of the Q mean that we want the absolute value. In other words, the magnitude or size only. We don't care if it's positive or negative for this equation. So let's put those numbers into our calculator. That gets us out a heat of 3,578 joules. So that was the heat change during our reaction. Now we need to decide if it's going to be positive or negative, because our answer here asks us for the enthalpy change of the reaction and to enter a negative sign for negative numbers. So in this reaction, our temperature of the water increased. What that means is that the water absorbed heat. If the water absorbed heat, that must mean the reaction released heat. So if the reaction released heat, that means it's exothermic, meaning we have a negative sign on our heat. So the heat change without those lines, showing that we do need a positive and negative sign, is going to be negative 3,578 joules. So we can enter that down here. Now we also need to find that in kilojoules, since our enthalpy change of reaction is given in kilojoules per mole of reaction. So we're going to need to convert from joules to kilojoules. So let's do that now. We have negative 3,578 joules. Let's set up our dimensional analysis table. And we need to convert from joules into kilojoules. Now remember, kilo means 1,000. So 1 kilojoule is equal to 1,000 joules. So that's going to be our conversion factor here. We've got 1 kilojoule is equal to 1,000 joules. So to do our calculation, it's going to be negative 3,578. The joules cancel out. It's multiplied by 1 kilojoule, and divides by 1,000. So that gets us out negative 3.578 kilojoules. Awesome. Okay, so we figured out the enthalpy change of this reaction with that amount of phosphorus. Now I need to figure out what mass of phosphorus was in the sample so that this is the enthalpy change we ended up with. So this is now our stoichiometry problem. And we're going to do this using the enthalpy change we just found as our given variable. So negative 3.58 kilojoules. So we're starting with the enthalpy change. We're going to need to first find how many moles of reaction cause this enthalpy change. We're going to then need to convert from moles of reaction into moles of phosphorus. And finally, we're going to be able to convert that into grams of phosphorus. So let's set up our dimensional analysis table. For the first step, we're going to be using the enthalpy of reaction as our conversion factor. The enthalpy of reaction tells us that in 1 mole of reaction, the enthalpy change is negative 738 kilojoules. So that's our conversion factor for our first step. So we've got kilojoules on the bottom, so that will cancel out, and moles of reaction on the top. 1 mole of reaction has an enthalpy change of 738 kilojoules. Okay, next we want to go from moles of reaction into moles of phosphorus. So we can see from our equation, we've got a coefficient of 1 on phosphorus. So that's telling us that 1 mole of reaction has 1 mole of phosphorus. So there's our conversion for step 2. We're going to have moles of reaction on the bottom so that will cancel out, and moles of phosphorus on the top. We have 1 mole of reaction includes 1 mole of phosphorus. Lastly, we need to convert into grams. So we're going to head to our reference sheet. Here's our periodic table, and we're looking for phosphorus. Here it is. So phosphorus has an atomic mass of 30.97 grams per mole. Our compound is P4, so we're going to have 4 times 30.97, which gets us a molar mass of 123.88 grams per mole. What that means is that 1 mole of phosphorus has a mass of 123.88 grams. So that's going to be our conversion factor for this last step. Moles of phosphorus is going to go on the bottom, and grams of phosphorus is going to go on the top. 1 mole of phosphorus is equal to 123.88 grams of phosphorus. Okay, so we've ended up in the unit we're trying to find. We can go ahead and multiply everything on the top, multiply everything on the bottom. We're going to divide top by bottom. So any units that are the same, top and bottom will cancel. So kilojoules cancel, moles of reaction cancel, moles of phosphorus cancel. We're left with negative 3.58 multiplied by 1, multiplied by 1, multiplied by 123.88 grams of P4, divided by negative 738, multiplied by 1, multiplied by 1. If we put that into a calculator, we're going to get out 0.601 grams of P4. So that is our mass. We can put that down here. So when we react 0.601 grams of phosphorus with an excess of bromine, it's going to have an enthalpy change of negative 3.58 kilojoules. So you can see in this question, we're combining firstly using the specific heat equation to figure out the enthalpy change of reaction based on the effect it had on the water that the reaction chamber was immersed in. Then we're using that as the enthalpy change for our reaction, and we're using stoichiometry to figure out how much of our reactants we had.